Good afternoon, Mandal. Regarding the structural analysis 1, the subject code is 20 CE 502. We can see the unit 2 moving loads and influence lines. Here, influence line diagram. The influence line diagram is mainly for moving loads. The moving loads, for example, we are traveling in a bridge uh, through a bus, is a moving load because the load is not permanent. In a building the load of RC elements is a permanent load, but moving load is different. A train moving over a bridge, that is called a moving load. The load is different. So here the analysis of moving load is only because of the influence lines. So influence line diagram is mainly for moving loads. The influence line represents the variation of either the reaction, shear force, bending moment, or deflection at a specific point in a member. As a unit concentrated force move over the member, the forces move from one end to another end of the beam. The construction of influence lines in the present approaches, it is assumed that the moving load is having dimensional magnitude of unity. Because of from the influence line diagram, the calculation of shear force and the bending moment will be same, but the unit is different. The unit for shear force is kilonewton, and the unit for bending moment is kilonewton meter. But the calculation formula is same. That means for point load, calculation of shear force is load into ordinate, and also for bending moment through because of the point load, the bending moment also calculate by the same formula, load into ordinate. But in case of UDL, load into area of the diagram, that is for shear force, and also for bending moment, load into area of the diagram. So here the design analyzes the beam for various position of loads so as to get maximum shear force and bending moment values due to the moving loads. To identify the position of loads for maximum shear force and bending moment at specific sections, influence line diagram can be used because to calculate, for example, we can consider five loads, five wheel loads acting. That means the five wheel loads are different. That is the condition we can assume, so the loads are different, and also the position of the load cannot be same to calculate the maximum shear force and for bending moment, because of the load can be maybe anywhere in the beam. So the if the load get moves and load get varies, and the shear force and bending moment also get varies. The influence line diagram is explained and used for finding maximum values of shear force and bending moment values. So definition of influence line. In the literature, researchers have defined influence line in many ways. Some of the definitions of influence lines are given below. An influence line is a diagram whose ordinates, which are plotted as a function of distance along the span, give the value of an internal force, a reaction or a displacement at a particular point in a structure as a unit load moves across the structure. A move influence line is a curve, the ordinate to which at many points equals the value of some particular function due to unit load acting at that point. An influence line represents the variation of either reaction, shear, bending moment, or deflection at a specific point in a beam as a unit concentrated force move over the member. As I already told, the moving loads moves from one end to another end of the beam. The influence diagrams are drawn for various stress resultants like reaction, shear force, bending moment at specific points. Influence diagram for stress resultant is the one in which ordinate represent the value of the stress resultant for the position of unit load at the corresponding adjustment. For example, if figure 1 represent ILD for moment at section C in the beam, then the ordinate O represents the value of bending moment at C when a unit load is acting at a section 1 1, because the maximum bending moment of the beam is will be acted at the C point only, but the load is acting at some distance from C. The Z is denotes the difference between A to B. A to B is L, and distance between the span A to C is Z. Sign convention. So the positive bending moment here, the zagging is positive bending moment and hogging is negative bending moment. Sign convention followed for shear force and bending moment diagram. So here the load is acting and the shear force is calculated. The positive shear force and for positive moment, the load is acting as sagging. So construction of influence lines. The construction of influence lines can be done by using one of the two approaches. One can construct the influence line at a specific point P in a member for any parameter. That means reaction, shear force, and bending moment. In the present approaches, it is assumed that the moving load is having dimensionless magnitude of quantity. Classification approaches for construction of influence lines is given in figure. So concept of influence lines, tablet value or influence line equations. That means the influence line diagram can be drawn and also for the shear force load into ordinate and for bending moment load into ordinate for point loads and for bending moment and for shear force for UDL load, the load into area of the section can be taken. So table form, apply unit at different locations along the member, say at X, and these locations apply statistics to compute the value of parameter at a specific point. The best way to use the approach is to prepare a table because preparing the table it is easy to calculate and also is easy to analyze the load for different conditions and for moving loads, for wheel loads. It cannot be same at the all point and also the location of the load can be vary from one place to another place. That means throughout the beam from starting to end, the moving loads can move. Listing unit loads at X versus the corresponding value of the parameter calculated at a specific point and plot the tablet value so that influence and segments can be constructed. Influence equations. Influence lines can be considered by deriving a general mathematical equation to compute the parameters. Example, reaction, shear force and bending moment at a specific point under the effect of moving load at a variable position of X. Influence diagram for simply supported beam. Simply by influential equation, the influential diagram for reaction at support A and support B, that is RB, shear force and bending moment at a section at distance Z from A are drawn. ILD for reaction at A, that is unit load is acting from A, that is distance of X. So that the unit would be at X from support A as shown in figure. By taking moment at support B, find out the reaction. RA into L equal to 1 into L minus X. That is RA equal to 1 minus X by L. When X equal to 0, RA equal to 0. When X equal to L, RA equal to 0. That means both A and B, the value of reaction is 0. Hence, ILD for reaction at A, RA is shown in figure. A and B, so the load is acting 1 that directly comes to the shear force that is value is equal to 1. So ILD for reaction B, by taking moment at A, find out the reaction RB into L minus equal to 1 by X, 1 into X, RB equal to X by L linear variation. When X equal to 0, RB equal to 1. When X equal to L, RB equal to 1. Hence, ILD for reaction at B, RB is as shown in figure. That means reaction at A, reaction at B. Reaction B equal to 1. So ILD for shear force at C. When X is less than Z, shear force at C equal to FC equal to minus RB. That is minus X by L, linear variation. When X equal to 0, F equal to 0. When X equal to Z, F equal to minus Z by L. When X is greater than Z, shear force at C, Fc equal to Re equal to L minus X by L, linear variation. When X equal to Z, Fc equal to L minus Z by L. When X equal to L, Fc equal to 0. The figure shows the diagram of ILD for shear force at C. That is L minus Z by L. That is Z by L. That is, simply we can take it as the distance from C to B divided by A to B. Here A to C divided by A to B. So ILD for moment at C, let C be the section at a distance Z from A as shown in figure. When X greater less than Z, MC equal to RB into L minus Z equal to X by L into L minus Z, linear variation with X. When X equal to 0, MC equal to 0. When X equal to Z, MC equal to minus L Z bracket L minus Z by L. When X is greater than Z, MC equal to RA into Z, that means L minus X by L into Z, linear variation with X. When X equal to Z, MC equal to Z into L minus Z by L. When x equal to L, MC equal to 0. Hence, ideally for moment at C, MC is shown in figure. Here, Z into L minus Z by L, the distance A and B, that is L, and A to C. Here, the Venn diagram will be like this. So influence and diagram for cantilever beams. The cantilever beam is for insulin diagram is different. Consider a cantilever beam of span L as shown in figure. Influential diagram for shear force and bending moment at fixed end A and at C are determined. Let a unit load act at a distance x from the free end B. So is it A, B and C. The unit will acting bit from C to B. That is 1. So dot distance from C to B is Z and distance is L. So ideally for shear force at A is 1. The red diagram will be rectangle. But in the previous case, the shear force diagram is triangle. For A, 1, and for B, that is also RB equal to 1. Ideally for bending moment at A, so moment at A equal to MA equal to minus L into L minus X. So linear variation. X equal to 0, MA equal to minus L. The X equal to L, MA equal to 0. That means ILD for MA is shown in figure. Only for shear force at A, x is greater than z and h is less than z. So here x equal to z and f equal to 1. Here x equal to z and f equal to 0. This is a diagram for influence and diagram. Shear force. So I only for moment at C. When x less than or equal to z, x equal to z and m equal to 0. When x greater than z, m equal to 0. Thank you for your patience listen.